Welcome back to the wonderful world of astronomy. We're in Chapter 7, studying our planetary system, which is generally referred to as the solar system. And this video is Part 4, Patterns in the Solar System. As we're studying the solar system, we're going to cover 4 chapters. So right now we are in the midst of Chapter 7, our planetary system. Then we're going to look at Chapter 8, the formation of the solar system. So particularly in this video, we're going to look at patterns in our solar system that give us clues as to what physical processes took place that formed our solar system the way it is. So in Chapter 8, we'll look at the formation. Then we're going to skip some chapters in the book. We're going to go on to Chapter 12, which is on the smaller bodies in the solar system. So we'll look at asteroids, comets, and dwarf planets. And then finally, we'll look at Chapter 14 on the sun. Let's now look at patterns in our solar system. A review from the previous 2 videos. We looked first at the terrestrial planets, which are the 4 closest planets to the sun: Mercury, Venus, Earth, and Mars. And then we looked at the Jovian planets in the last video: Jupiter, Saturn, Uranus, and Neptune. And I want you to remember the main characteristics of those 2 groups of planets. So the terrestrial planets are the closest to the sun, the Jovians are the farthest. The terrestrials are relatively small, the Jovians are relatively large. The terrestrials are high density, the Jovians are low density. The terrestrials are mostly solid rock, the Jovians are mostly gas. The terrestrials have few, if any, moons, and the Jovians have many moons. And finally, the terrestrials have no rings, and the Jovians have rings. This is a table in Chapter 7. It gives much data about the different planets. It gives a good comparison of different characteristics. So here they are, the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And I do expect you to have those memorized, be able to spell them correctly, and know them in order. I want you to look here in the second column, relative size. And so you can see these tiny dots that are Mercury, Venus, Earth, and Mars, and then the larger ones, Jupiter being the largest, then Saturn, Uranus, Neptune, and how much bigger those Jovians are than the terrestrial planets. Average distance from the sun, you can see, obviously, if they're listed in order from the sun, they get progressively larger distances. That's in astronomical units. Of course, Earth is 1 astronomical unit. And I'll cover in another slide soon a way to remember these. Equatorial radius in kilometers, that just has to do with, that's how big it is. And you can visually see those in these diagrams on the left. The mass of each planet. Mercury is by far the least massive, and then Mars at 11%. These are scaled to Earth's mass, so Earth equals 1. And then you can see the most massive planet, Jupiter, being 318 times the mass of Earth. Average density, remember I said that Saturn is the only planet with a density less than 1 gram per cubic centimeter at 0.7. And actually Earth, well, all the terrestrials are the denser ones, but Earth in particular is the densest. The orbital period. I want you to remember Kepler's 3rd law of planetary motion that says the farther out a planet is from the sun, on average, the longer it takes to go around. And here we see Mercury with an orbital period of 87.9 days, and they get progressively larger. Venus at 225 days, of course, Earth is a year. We see Mars, Jupiter at almost 12 years, Saturn 29.5, and we get on to Neptune, which is 165 years to go around the sun. Rotation period. These have great variety to them, and you can see Mercury has a very long rotation period. It takes 58.6 days to rotate on its axis. Now, especially when you compare that with its orbital period of 87.9 days, a day on Mercury, the time it takes to spin, is almost as much, about 2/3 of its orbital period. Venus is even more extreme. Notice that Venus's rotation period is greater than its time to go around the sun. Of course, Earth is about 24 hours, and the fastest spinning planets are Jupiter and Saturn. And that's very weird. The largest planets are the fastest spinning, and particularly with Jupiter, that's what leads to its stormy weather. There's a lot of storms on it, a lot of very high winds on Jupiter. The tilt of its axis, you've learned earlier in this class that Earth is tilted 23.5 degrees from the plane of its orbit. And you can see all these other orbits. Notable exceptions are we have Uranus tilted at 97.9 degrees. So it is on its side and then tilted a bit more. Venus is peculiar, 177.3 degrees, which is basically upside down. If something is turned 180 degrees, that means it's upside down. So Venus is turned 177.3 degrees. What that means is that effectively it rotates on its axis backwards. If you take something and you take a water bottle, a ball, whatever, and you spin it, and then while you're spinning it, turn it upside down, you'll see that it's spinning. If it was originally spinning counterclockwise, now it's spinning clockwise, and that's what Venus is doing. Average surface temperature, it says or cloud top temperature. And you can see Mercury can be very hot, but also very cold at night. Venus is the hottest temperature on average. And you can see in general, as we go away from the sun, the average temperature gets lower and lower. And then the composition, remember I said terrestrial planets are mostly rocks and metals, and then the Jovian planets, hydrogen, helium, and some hydrogen compounds. The approximate distances to the sun, I'd like you to learn these. It gives you a good rough scale of the solar system to have these numbers in mind. Earth, you should definitely know, is 1 astronomical unit from the sun. You should know that because that is the definition of 1 astronomical unit, which by the way is 93 million miles. Mars is 1.5 times that, so 1.5 astronomical units. On this chart, you'll see rough approximations. You saw on the previous page the more precise numbers, but these are rounded off and they show a very nice, easy numerical pattern. So Jupiter is 5 astronomical units from the sun, 5 times as far away as Earth is. Then, if you're going out to Saturn, you're going from the sun to Jupiter, go out to Saturn, you double the distance that it was to Jupiter. So it was 5 astronomical units out to Jupiter, 10 astronomical units out to Saturn. And you can see in my picture here, if you're going from the sun to Jupiter, there's 5. Double that distance, you're at Saturn, which is about 10. The next planet, you're going to double that distance. So to get to Uranus, it's another 10 astronomical units. Now you're at about 20 astronomical units. Neptune is 30 astronomical units. And Pluto, no longer considered a planet, but we'll throw it here anyway. Pluto is 40 astronomical units. So very easy to remember, starting with Jupiter, 5, 10, 20, 30, and 40 astronomical units. Here is a picture of all the planets, not to scale, but it shows their tilts on their axes. And you can see quite the difference. Very notable is Venus. It doesn't look tilted that much. It looks tilted maybe 3 degrees. But remember, we say it's tilted 177 degrees. It's almost upside down. But notice the arrow showing its rotation. It's rotating in the opposite direction as all the other planets. Now, the question could come up, why don't we just say it's tilted at 3 degrees, that's less extreme than 177, and just say that Venus orbits backwards? Well, this gets into formulating theory about how the solar system formed. And as we'll see when we get into chapter 8, it just seems like a more reasonable explanation that in the way the solar system formed, that Venus got turned upside down rather than that it's spinning backwards from all the other planets. You can see Mars tilted about the same as Earth, Jupiter tilted very little, Uranus on its side. Now the next slide shows it with those tilts, but also with the rotation. And the person who made this video put little faces on the planets just so you can see better the rotation rates. And notice Mercury and Venus rotating very, very slowly. Venus is imperceptible in its rotation, but it is rotating backwards from the other planets. You can see Earth and Mars. Ceres is the largest asteroid. We'll talk about it more in chapter 12. We see Jupiter and Saturn going very, very fast. Notice Uranus spinning on its side, and then Neptune. And Pluto, the dwarf planet Pluto, is tilted at a very extreme angle, 122 degrees. Now we'll look at what features of our solar system provide clues to how it formed. So this is going to be our lead-in to chapter 8, which describes the formation of the solar system. This screen shows a picture that is in the textbook. The writing is too small, so what I'm going to do is on the next few screens, I'm going to zoom in to one section, and then the next section, I'll just zoom in on each of these sections. But here you have the large picture of the sun, the planets going around the inner solar system, then Jupiter, Saturn, Uranus, and Neptune. And then beyond Neptune's orbit is a bunch of comets that I'll talk about. So let's look at these various sections, starting with in the upper left hand. All large bodies in the solar system orbit in the same direction and in nearly the same plane. So you look down at the picture below, you can see this is zoomed in, the sun with the inner planets, they're all going around counterclockwise. And then we zoom out more, we see the outer planets, they're all orbiting around counterclockwise, that same direction. And it says most also rotate in that direction. The sun rotates in that counterclockwise direction. Mercury, Earth, Mars. Now Venus is the exception, it goes backwards, but Jupiter, Saturn, Neptune, they all rotate in that same counterclockwise direction. Uranus is another exception because it's on its side. Also, most large moons orbit their planets in the same direction, which is also the direction of the sun's rotation. And in the last video, I showed you a notable exception, which is Neptune's moon Triton, which rotates, it orbits backwards. We see in the solar system two major planet types, the terrestrial planets and the Jovian planets. You've already learned about those. Make sure you understand and know the characteristics between those. We also see in the solar system swarms of smaller bodies. There are many rocky asteroids and icy comets that populate the solar system, and we will talk much more about these asteroids and comets and these smaller bodies in chapter 12. Now, this picture shows, here's the sun, and in this brownish circle around it is the asteroid belt. Asteroids are made of metal and rock, and most of them orbit in the asteroid belt between Mars and Jupiter. Expanding outward, we have two regions of comets. Comets are icy. Here it says they are ice-rich, and many are found in the Kuiper belt beyond Neptune's orbit. And on the next screen, I'll show you the Kuiper belt. And then many, many more comets orbit the sun in this spherical region. Here it just shows it cut away, but a spherical region that goes out possibly as much as 1 light year, which is about a quarter of the way to the nearest star, Proxima Centauri. So it's called the Oort cloud. Here's another picture of the Kuiper belt. We have not drawn to scale, but the sun, the planets, we have Saturn with its rings, Uranus and Neptune, and this strange orbit here, that's Pluto. And the Kuiper belt starts pretty much at Neptune's orbit, which remember is 30 astronomical units from the sun, and it goes out to about 100 astronomical units from the sun. That's the Kuiper belt, where comets orbit around the sun. We have short period comets. There are some comets that orbit and come very close to the sun. This is actually an animation of Halley's Comet, which comes around every 76 years. So it goes in, whips in towards the sun by Kepler's second law. The farther it is, the slower it goes. And the closer it is to the sun, the faster it goes. And Halley's Comet, as I'm making this video in 2024, it is at about its perihelion. I'm sorry, it's aphelion. It's farthest place from the sun, right about there. And give it another 38 years, roughly, and it will be at perihelion, and we'll be able to see it again in the sky. But these are short period comets that come in towards the inner solar system. Now, we see all these major patterns in the solar system, but as we're pondering, how did the solar system come to be the way it is? How did it form? We have to take note of the exceptions to the rules, and a good theory is going to have a reasonable explanation for these exceptions. So some notable exceptions that I want to remind you of is that Uranus has an odd tilt to it. Venus also has a very odd tilt, or we might say Venus rotates on its axis backwards. And we need to have a theory that gives some explanation for that. Also, another notable exception, not shown on this page, but that Triton is a large moon that goes around Neptune that orbits backwards around its moon. I'm sorry, around its planet. We have to have a good explanation for it. Also, Earth's relatively large moon, there needs to be a good explanation for that. And we will talk about all of these patterns and the exceptions to the rules and come up with a theory of how the solar system formed when we get to chapter 8. That is the end of part 4 of chapter 7, Patterns in the Solar System. Have a great day.